Hello everyone, in this video we will see how to draw an ellipse by focus directrix method. But before that, let's look at the definition of an ellipse first. Ellipse is a curve traced out by a point which moves in a plane in such a way that its distance from a fixed point, that is focus, to its distance from a fixed straight line, that is directrix, is always remains constant and is always less than 1. So this definition is telling you about the definition of an eccentricity also. So let's look at the definition of an eccentricity now, and simultaneously we will understand the definition of an ellipse as well. So this is the point P. Assume that this point is moving continuously and it is tracing this elliptical path. So if we measure the distance of this point P from the focus F1, that distance would be PF1, and if we measure the distance of the same point from the directrix DD dash, which is PM, and if we take the ratio of these two distances, that is PF1 upon PM, then that ratio will be always less than 1. So the definition of an eccentricity is it is the ratio of the distance of the moving point from the focus to its distance from the fixed straight line, that is directrix. And at the same time, we can define an ellipse as it is a curve having an eccentricity less than 1 and that always remain constant wherever the position of point would be. So let's look at the focus directrix method to draw an ellipse. Let's look at the problem statement first. Draw an ellipse having the distance of a focus from the directrix 50 mm and eccentricity is 2 by 3. So you can see here two things are given. First one, the distance of the focus from the directrix, and second one is an eccentricity. So now let's see how to draw an ellipse by having these two given data. First up, we will draw a vertical straight line which we will call it as directrix D dash. And then we will draw a horizontal line from the midpoint of the directrix. This is going to be the axis of our ellipse. Let's call that point of intersection of an axis and directrix as O. Now let's use the given data. So in a given data, it is given that the focus is at a distance of 50 mm from the directrix. So let's mark the focus first by taking a distance of 50 mm from point O. OF is equal to 50. Next, we have to locate the vertex which will be in between O and F. So to locate the vertex, we will divide OF into 5 equal parts. Why 5? If you look at the eccentricity given, it is 2 upon 3. So we will add the numerator and denominator values, which is 2 and 3 over here. So 2 plus 3 would be 5. So we will divide this OF into 5 equal parts. Like this. And after that, one of the point is our vertex. So how to find out which one is vertex? So if you look at the eccentricity, which is 2 upon 3, and that will be equal to VF upon OV. So this tells you that your vertex is at second division from F or it is at a third division from O. So second division from F, here we will locate our vertex. The next step is to use that vertex. To remember the procedure of any curve, what you simply need to understand is whatever you are plotting, you have to use it. and that is one of the way to remember the procedure. So as we have plotted over here the vertex V, so it's a time to use that. You just need to remember how to use it. So here we will use the vertex by drawing a perpendicular line to the axis of an ellipse passing through the vertex. Next we will use this line and the focus and the vertex. We will take the distance in a compass V to F, and V will be the center, and we will draw an arc which will intersect to this vertical line passing through V. Let's call that intersection point as A. Now let's connect OA and extend it further. After that, we will draw a line inclined at an angle of 45 degrees with the horizontal from the focus, and that line will intersect here to line OA, and we will call that point of intersection as B. After that, we will use the B and we will draw a vertical line passing through B and intersecting the axis of an ellipse, and that point of intersection gives us another vertex of an ellipse, and we will call it as V dash. So here if you notice, we have got our major axis of an ellipse which is VV dash. The next step is to divide the major axis into equal or unequal number of parts. So how many parts? So I will suggest you to divide it into minimum 8 number of parts. More the parts you divide, more the perfect ellipse you will have. So let's divide this V2 V dash into number of parts. Let's name all these points which we have just plotted. 1, 2, 3 up to 8. Now let's use all these points. So how to use them is very simple. You just need to draw the vertical lines from all these points like this. Make sure all these vertical lines are intersecting to the line OAB. And these points of intersections of vertical lines with OAB, we will call them as 1 dash, 2 dash, 3 dash up to 8 dash. And the next step is to locate the points on all these vertical lines. How to do that? So you need to take your rounder, take the distance in a rounder which is 1 to 1 dash. F will be the center, that is focus, and then cut an arc on a line 1 to 1 dash on top as well as at the bottom. Similarly, we will take the distance 2 to 2 dash. At this time the center will be the same. In fact, for all the times whenever you are going to cut the arc on every line, the center is going to remain same, that is focus. Only the distance which you are going to take in a rounder, that will get changed. So previously we had a distance 1 to 1 dash, and this time we are going to take the distance 2 to 2 dash, but the center will be the same, that is focus. And we are going to cut arc on the line which is passing through 2 to 2 dash on the top side as well as at the bottom side. So can you guess what will be the distance next time? Yes, you are right, 3 to 3 dash, and the center will be good, that will be F. So let's cut arc on the line 3 to 3 dash onto the top as well as bottom. So you keep on doing this by taking a distance 4 to 4 dash and cut arc on the lines, then 5 to 5 dash, keep on cutting the arcs and getting the points to draw an ellipse. Once you get all these points on all these vertical lines, we have to connect all these points with a smooth curve. So it's better to use a French curve. If you're not so friendly with the French curve, you can join all these points freehand. Make sure that the curve which you are going to draw here, it must not have any sharp edges or the sharp points. it must be a smooth curve. So at the end, after connecting all these points, you will get an ellipse. And finally, we have to name all these points on this ellipse as P1, P2, P3 up to P8 at the top side. And similarly, P1 dash, P2 dash, P3 dash up to P8 dash at the bottom side. And then we can name this curve as an ellipse.